Hello guys, my name is Balkrishna Srivastav and welcome to CodeWithBK. So in this video, we write a function to delete the last node in the linked list in C programming. So before we begin, it is a request to please subscribe to my channel, and if any of my previous videos has helped you out, or if this video helps you out, so please do subscribe to my channel. Okay. So we write a function to delete the last node in the linked list in C programming, and we saw functions in C programming to find the length of a linked list, get the value at a given index in the linked list, print the linked list in reverse, insert at end, insert at front, insert at a given index, delete from front, and delete and get the value that has been deleted from the front. And then here in this case we delete the last node. Okay, so all of these functions are covered in detail in separate videos. The link for those videos you can find in the description of this video. There is a separate playlist as well. And before all these functions, I explained in detail, in very detail, what is a linked list, what is the idea behind a linked list. Linked list basically nodes linked together. Okay, and we link nodes together using this next pointer. Okay, so a linked list is basically multiple node objects, in this case struct node objects, linked together using this struct next pointers, because using this you can go from one node to another node. Okay, so in this video we cover this function to delete the last node, and just as we saw for delete front, we had a corresponding function to delete and get front. By the end of this video we'll also see delete and get the last node, so that we have another function to retrieve the last node that we have deleted. Okay, so suppose if you have a linked list, okay, and this is my head, I have to delete the last node. Okay, so the last node is this value, is this node with this value 27, and I want to delete this. So I should have the remaining linked list as 4, 11, 13, 100 and null. Okay, I got rid of this last node with the value 27. My head stays at the same position. This is my problem description. Okay, let's look at the possible cases here. The first one obviously being list is empty. So if the list is empty, that is if head is null, we do not do anything, return null, that is return head as it is. Okay, the second case, list being not empty, will divide into two cases. First is list has one node. So this is the case where head is pointing to say a node with the value 17, pointing the next of which is going to point to null. Okay, so deleting the last node in this case is deleting this very node. Okay, the only node in this linked list in this case, so the linked list goes empty. Okay, so if the list has one node and if you have to remove the last node, okay, list becomes empty. Okay, understanding by the fact that if the list has one node, that is the first node and that is the last node in the linked list. Okay, and the third case being list has more than one nodes. Okay, greater than one nodes. Okay, we'll see about this. Okay, so let me just implement this function. So if the list is empty, if head equal to null, we simply return head. Okay, if the list is empty, return the empty list. There is nothing that we can do. Okay, we do not have any last node to return. If the list has one node, if head dot next equal to null, that is how we check if the list has one node, because the next of the head is going to be null. Head will be pointing to the first and only node in the linked list. Okay, if the list has one node, has only one node. In this case, we remove this only node, so the list becomes empty, so we have to return null. Okay, so in the case of one single node, we have to remove that one node, and in this case of C programming, nodes are dynamically allocated. So if you are removing a node, if you are deleting a node, you make sure that you free the memory that has been occupied by that node. Okay, so free the memory occupied by this head node. So I can simply say free head, and then I can return null. Okay, it is in this very specific case that I can say free head, because I want to get rid of the memory pointed by head, and head dot next is null. Head has only one node, so when you free head, you delete the only node, which is the first node in the linked list. Otherwise, when we are removing the first node, we don't do free head directly. Okay, so if you look at delete front function, okay, there is nowhere that I have done free head directly, and I've explained in this video where I delete the front why don't we do free head directly. Okay, because when you do free head and if the list has multiple nodes, free head will only deallocate memory of the head node and the remaining nodes will still be there. That will cause memory leaks. Okay. All right. So going back, so this is done. Case for empty list, case for single node, and else. Okay. Okay. Case where the number of nodes in the list are greater than 1. Okay, so in this case you have to disconnect the last node by moving on to the last node. Okay, so this is my last node, say. Okay, this has to be disconnected from the remaining list. Okay, so this node, okay, this is second last node. Okay, the next of this second last node should be pointing to null and not to this node. Okay, so you can say move to the second last node. Okay, then disconnect last node from second last node, right, and free memory of last node. All right, so following this is my second last node, the node with the value 100, node with the value 27 is my last node. We'll see how we reach these nodes. Okay, we say disconnect the last node from the second last node, so the next of this is set to null. So we have head pointing to 4, then 11, 13, 100 null, this particular list that we want, but we still have this node with this value 27. We free the memory for this node, so this is now lost. Okay, nodes which cannot be referenced anymore, okay, by any variables will not be automatically collected by garbage collector. It is not the case of Java programming where garbage collector collects the nodes which cannot be reached. Okay, so the memory occupied by these nodes must be freed by the user. That's why we free this memory for this node. Okay, so case 1, case 2, and these 3 points for case 3. Okay, so this and this is easy. We can simply say second last node dot next is null, and then we can say free last node. How do we get second last node and last node? We use 2 pointers. We say current and previous. Okay, let me just draw this linked list again. I say 4, 11, 13, 100, 27 and null. Okay, I'll take my current. This is a node pointer current and this is a node pointer previous. I'll take my current pointing to the second node. I'll take my previous pointing to head node. So we say current is head dot next. Okay, because this is my head. Head's next, current is pointing to that, and we say previous is head, so previous points to head node. Okay, so this idea of previous and current pointers remains the same whenever we are trying to traverse a linked list. Okay, and this idea remains same across programming languages as well, in Java and C, C++, and Python. Okay, previous will always be tailing this current node. It will be right behind this current node. Okay, so if current moves on to 13, previous will move on to 4. Current moves on to 100, previous moves on to the node with the value 30. Okay, so in order to move to this last node, we say while current dot next is not equal to null. Okay, and we say previous is current and current is current dot next. Okay, so initializing current and previous and then running this loop. Okay, so when you initialize current and previous, we have something like this. Head is pointing to the first node, previous pointing to head, current is pointing to head dot next. You say current dot next is not equal to null, current dot next is not equal to null. Let me just write this condition. Equal to null is true in this case. Okay, this next is not null. So you say previous is current. So previous points to where current is pointing to, and current is current dot next. So current points to where current dot next is pointing to. So you see both previous and current moved a node ahead, and previous is right behind current. Okay, then you go back to check for the condition again. Current dot next is not equal to null. Current dot next is this node with the value 100 is not null is true again. Okay, so previous is now current. Previous points to this node. Current points to current dot next. Okay. Going back to check for the while loop condition, current dot next is 27. Current is pointing to this node with the value 100. Next is 27, not null. Condition is true. you say previous is current, so previous now comes to this node and current now moves to this node. Okay, you go back to check for while loop condition, current dot next is not equal to null, current dot next, current is at 27, next is null, condition is false. Okay, so current stops at last node. Okay, and since previous is right behind it, previous stops at second last node. Okay, so after this loop you can say node pointer last node is current and node pointer second last node is previous. And then you can say disconnect last node, so you can say second last node not next is null and free the last node. Okay, now I'll say when previous is initialized to head and current is initialized to head dot next, they won't both be null. Okay, in this case, because this is the case where we have at least two nodes, greater than one node. Okay, so if there are at least two nodes, I have the first node and the second node, previous is at first node, current is at second node. Since there will be at least two nodes, so these both won't start with null, so I can safely do this initialization and then run this loop. Okay, so if you want to consider this case of two nodes linked list, so if you have head pointing to say maybe 19 and 21 and null, so previous starts here, current starts here, and we say current dot next is not equal to null, will be false in the very first iteration, so this loop will not run at all. Okay, for this linked list this while loop will not run. So we have last node at current and we have second last node at previous. Okay, because we have at least two nodes. Okay, all right, and after this we disconnect and free the memory, right? So let me just code this. Okay, then we do this part, disconnect. So you can say second last node dot next is null. Okay, and free the last free last node. Okay, right, and in this case head will always stay at the first node because this is the case of at least two nodes and we have to delete the last node, so head will stay at the first node. The case where head can change is this case. Okay, so this is your function to delete the last node. You really don't need these two pointers, you can simply say previous dot next is null and then free current. Okay, okay, this is just for demonstration that you understand the idea of last node and second last node. Okay, so let me just test this. So we already have delete and get front, right? So I'll replace this by delete okay, so we have this linked list 4, 13, 11, 127 and we delete last node one by one. Okay, so compile and run. So this is our initial list, we remove 27, this is what we got. Then in this list we remove 100, this is what we got. In this list we removed 11, this is what we got, last node. Removing 13, this is what we got. Removing 4, the only node, we got this list. And in this last delete last, the list that we are passing is empty, so nothing happens, and you can see the length also decreases by 1 in each case. Okay, so this is your delete last node. We can also have a corresponding and get last node, and I can pass a removed value pointer to save the value that we have removed. Okay, so I will implement this function in the very same way. Okay, just saving the value, okay, before we delete the node. All right, so I have free head, so I'll say removed value is the value at head. Okay, and in this case the remove value is the value at last node. save the value to be removed. Okay, save the value to be removed, free the memory occupied by this head node, right? So let me just replace all these deletes by delete and get last. So we will be removing the last node and also printing the value that was removed at that node. So I can just keep copy and pasting this. Okay, all right, and this is our function. Oh, this is star remove value is a pointer, apologies. All right, compile and run. So deleting the last node from this list, we get 27, and this is the resulting list. When we pass this list, the last node is the value, the node of the value 100, which we remove, we get this. When we pass this list, the last node is 11, which we remove. Passing this list, last node is 13. Passing this list, last node is 4. Remove value will stay 4 because when we are passing an empty list, nothing happens. Okay, so the value, the value in the variable, the pointer, remove value does not change, so it remains 4. Okay, one last thing is minor, but I think there are cases where I have seen students make error, is when you're trying to free memory that has not been dynamically allocated, because you are always being taught to delete the memory that has been occupied by a node. The memory occupied by a node should only be freed if it was allocated dynamically. In this case, where we have nodes like this, okay, nodes are just variables. These variables are allocated on stack memory. Dynamically allocated memory comes from the heap memory. Okay, that you can free. This, if you try to free, it's a problem, these variables. So I'll show you. So let me just comment all this. Okay, if I have, say, delete last, okay, so I have a list 1 2 3 4 5 null. Let me just print. Okay, not just, I just comment this out. I'll get 1 2 3 4 5 null. Okay, the difference being that these nodes are variables. I'm setting the x values and I connect these using the next pointers. Okay, these are variables, that's the key. These are not dynamically allocated. So printing this, I get 1 2 3 4 5. Okay, length is 5. Now when I try to delete the last node is n5, which is not dynamically allocated, and you are using this, and you are using this free last node, which will not work. Okay, so if I clear, compile and run, okay, pointer being freed was not allocated. Okay, because this was not dynamically allocated. Okay, so if your nodes are not dynamically allocated, you do not need to free them. Okay, keep in mind this. So that was this demonstration. Let me just uncomment this and let me just run this again. Okay, clear, compile and run. Okay, and this is how you remove the last node in the linked list. So I hope you like this video and this was helpful. So if there is any doubt, there's a part you don't understand, please let me know in the comments. I always try to answer all your comments. And you can also let me know in the comments if there's a question you want to solve or if there's content you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.